All right. Good morning, everybody. And thank you for coming after a pretty hectic party last night. So I'm sure many of you enjoyed that. But thank you for being here today. So today we'll be discussing 3 new services that were introduced on Monday morning on the AWS console. AWS Elemental Media Store, AWS Elemental Media Package, and AWS Elemental Media Live. And this is a 200-level course, so we're not going to dive deep into code or anything like that, but we can go into as much detail as you want. Ask questions at the end. You can raise your hand and ask questions or come up and talk to us. So my name is Aslam Khadir. I'm the Chief Product Officer at AWS Elemental. For those of you who don't know, AWS acquired Elemental about just over 2 years ago. We are based in Portland, Oregon. We are now an integral part of AWS, as demonstrated by the launch of those 5 new media services on the console. Along with me, I have Andrew Tunnell here, who's product manager for MediaStor. So he's responsible for launching one of the products or services we'll be discussing here. And along with that, we have Chris Ferring here, who's we are very happy to have here, who's Solutions Architecture Manager for Pac-12. And as the title of the presentation said, he'll be going over some of the Pac-12 implementation that he's done using MediaStor. All right. So how many of you have deployed video workflows? That's pretty good. Just to level set, I'm just going to go over a little bit of kind of basics here so we make sure we're all on the same page, and then we'll dive deeper into each of the services. The first thing I want to talk briefly about is that these services, all the services that we've launched, are essentially applicable to any industry. Video is becoming core and central not just to the media and entertainment industry, but is being used extensively more and more in various industries, including things like enterprises for purposes of communication, and government for lots of surveillance and other kinds of use cases, as well as in the classroom. And all of these use cases that span the various industries are all relevant in terms of the services that have been launched. So if you're in any industry, if you're dealing with video, we know that the services we've launched will be applicable to you. Okay? So let's go over some key concepts of video, especially live video workflows, so we can all get on the same page. So, and the focus again, if you look at the video ecosystem, there's essentially a production ecosystem, there's a post-production ecosystem, and a distribution ecosystem. Most of what we've done here is focused primarily on the distribution ecosystem, which tends to be the largest. The production ecosystem is normally represented by studios and other entities that produce video content. The post-production is represented by studios and post houses that actually take and process that video content to create the kinds of variations that are required for distribution purposes. So the first thing to note is that when you are producing video, normally video tends to be in baseband. And baseband video is got a lot of gravity. It's extremely large in terms of both its size, its bandwidth requirements, and its storage requirements. As an example, if you have an HD video that you're producing, 1080p 30 HD video, it could take around 1.7 gigabits per second is the bandwidth that you're normally producing out of the camera. Okay, so that's baseband. So that's really hard to move around. So the first thing you do with video is, once you get it off the camera, is to really encode it. So you compress it down into a form that makes it a little bit easier to move around without actually giving up on any of its quality. And that happens through this encoding transcoding process, where you're essentially throwing away a lot of the information that the human eye can't perceive to just retain the information in your bit stream that the human eye perceives. There are codecs and things like that, which are basically encoder-decoder pairs, but there are codecs that represent best practices, and there are standards-based solutions such as MPEG-2, AVC, HEVC, that are different codec standards that are used to actually do this compression. So the first thing you do is you compress the video. Similarly, you compress audio And then there's a lot of data that you generally add to the video stream in order to ensure that there is more information about that video. Whether that metadata is about what's happening in the video, who is in it, or whether it's data such as advertising signaling to downstream allow systems to insert advertisements in the right places. So once you do the compression of this asset, whether it's a file asset or live asset, in this case, it's a live stream that you're compressing in real time, you then go ahead and actually package this asset. So you then create variations of this stream that are pertinent and applicable to different consuming devices. So if you're watching on your connected TV, you're watching through your set-top box, you're watching on your mobile phone, on your tablet, each of them tends to consume a different packaging format. And the common formats are HLS, which is the one that's normally used for most all Apple devices. Dash, which is an MPEG standard, which is used across a number of devices, including connected TVs. And Microsoft Smooth, which is a kind of a standard that's going away now, being replaced by Dash. But still, 30–40% of the devices out there consume Smooth. So these are different packaging formats that you need to put together so that you can reach as many devices as you wish to. As you put these packages together, you create what's called a manifest. And each of these have different manifest standards. So for example, HLS has something called an M3U8. A manifest is essentially a playlist. It gives you a list of every segment that's in the content. And in a live stream, you're constantly updating that manifest because every 2, 3, 4, 5, 10 seconds is what duration of your segment that we say. Every so many seconds, you're updating that manifest to write the new content that's just come in. Okay? And these manifests are used for various purposes. So the playlist gives the ability then to, if you manipulate that manifest, you can do things like do geo-blocking, you can do blackouts, you can do personalized ad insertion. There's a whole series of technologies that then come into play or use cases that come into play with this. You then, if you have premium video, you then may decide, hey, I really want to encrypt this video because I don't want anybody who gets hold of it to be able to watch it if they haven't, quote unquote, paid for it. So there are many standards around digital rights management that are available. The three primary ones that are used for all these devices are PlayReady, which is a Microsoft standard, but it's used across all devices. Widevine, which is a Google standard, and FairPlay, which is an Apple standard. So as again, you're looking at reaching all these multitude of devices, you need to essentially, you need to protect your content, so you encrypt it using these different standards. So now that you have your encrypted, you have your compressed, packaged, encrypted content, you then need to originate it. It then needs to get to a point where players can pull that content. So there's normally an origination server that handles that. So the content goes to the origination server and players are pulling from that origination server. And then finally you have your content distribution network, or CDN, that essentially caches the content so that every request that comes for the same piece of content doesn't have to go all the way back to the origin server, that it can be served from the edge POP or wherever it is that the CDN has its caches placed. Okay? So these essentially, if you look at how video then flows through just the distribution workflow, this tends to be kind of the process that happens. Okay, so I just want to then show in the context of all of these different technologies, how does that all come together as you put together a distribution workflow? So you see here there's a live workflow at the top and a VOD workflow at the bottom. I'm not going to focus on the VOD workflow since this session primarily is for live workflows, but keep in mind that all the services we've launched, we also have VOD workflow services that are part of what we've launched. So the first thing that happens is, like I said, from your camera, you have baseband to compressed IP video. So this block, this contribution block, which normally is called a mezzanine encoder, essentially takes high bitrate content and encodes it into an IP accessible lower bitrate content. It's still pretty high bitrate. It could be a 30–40 megabits per second AVC or MPEG-2 stream, or a 10 or 15 megabits HEVC stream. It's still pretty high bitrate, but it's much lower than what the content is coming from. Then normally a mezzanine encoder would feed a live encoder, which does real-time processing and creates all of the bit rates. There's a single bit rate that's coming into the live encoder, and the live encoder is then producing a number of bit rates for different resolutions and different qualities for different devices. Okay. So normally an ABR, it's called an adaptive bit rate. An ABR bouquet can consist of anywhere from 3 to 10 different resolutions and bit rates. That then is sent to, normally now, best practices is to use a just-in-time packager. And what a just-in-time packager does is that when a request comes from the client, from the player, it'll essentially look at the player client and it'll figure out, this is how I need to package this content because this player requires this content. So it'll just-in-time package the content, it'll just-in-time encrypt it, it'll do any manifest manipulation that's required, and then serve it out. And then that goes to the CDN, which essentially is getting the requests in and serving the content out. In addition, there are many use cases that are less complicated, that you may not want to do just-in-time packaging, that you've already pre-packaged the content, you've pre-encrypted it, you don't need to do any manifest manipulation. In those cases, if your manifest and your content is being produced on the ground or in the cloud, you can actually use a storage solution, an optimized media storage solution that acts as a high throughput origination server for a CDN. And then finally, for monetization purposes, many of you are looking for doing things like server-side ad insertion. Server-side ad insertion allows you to essentially have a broadcast quality, extremely robust stream that consumers consume, which has advertising stitched into it that's personalized to them, that gives them both a high quality of experience and does better monetization because it circumvents some of the ad blocking technologies that are out there. Okay, so that combination generally makes up, if you look at this workflow, makes up kind of the live workflow. Okay, so now that you've got a picture of what are the different building blocks in a live workflow, we'll talk about these media services. So the first service that we've launched is called AWS Elemental Media Live. So as the name suggests, it's a live transcoding service. And the challenge of a live transcoding service is that every frame that's coming in has to be transcoded in real time and output in real time so that you're watching a continuous stream and you don't get jitter or you don't get the player stalling because the content isn't available. So it's a live encoding service that's working. The best thing about this is that you can deploy it in minutes. So in the past, when somebody wanted to launch a new channel as an example or get a live stream going, they would have to go in and figure out, okay, what encoder do I use? How many encoders do I need? What's the specification of it? I had to rack it and stack it and wire it up and test it and make sure I had the proper cooling and power and then all of the infrastructure requirements along with the technology selection requirements that you had to go through. Now with this Media Live service, it takes you a couple of minutes, and we'll show that to you as well, where you essentially set up your input, set up a channel, send your content to these inputs, and voila, you have essentially a live channel that you can use either as a live event purposes for a period of time, or you can use it as a 24/7 channel. The other benefit is that this service allows it scales elastically, so you don't have to worry whether if you're coming up on the Olympics and you have the ability or you need to have 20 pop-up channels come up because you want to cover 20 sports in parallel at the peak time. You don't have to procure content. You don't have to worry about it. You just start up 20 channels and boom, you're good to go. And we manage all of the resource provisioning. We manage it's a fully managed service in that regard. The service is very resilient because it's been deployed as a redundant implementation, which means that when you define an input, we give you 2 IP addresses, which are fixed. When you define a channel, we actually start up we make available to you encoding resources for that channel in 2 separate availability zones in the region that you've selected. So it automatically gives you a redundant implementation. So it's extremely resilient so that if in that redundant implementation, if that resource happens to fail, we are constantly tracking it and the system will heal itself because it'll allocate another warm resource out to you that will be utilized seamlessly in your workflow. It's got built-in monitoring, which means we are constantly monitoring it. We have alerts and alarms set up. Our service team is constantly ensuring that the service is up and running and that if there's anything that's failing, we get alerted way before you ever see the impact of it. And because it's a broadcast quality solution, so in the past, you've had kind of cloud-based live services available, but they've really been very deprecated in terms of their functionality. This is a broadcast quality service, and it's based on Elemental's 10 years of transcoding and encoding experience in professional premium video. So it's got all of the encoding parameters that you would ever want to deal with. If you want to deal with them, you can tune them as you wish them. But we also set defaults, and we give you presets so that you can use those if you don't want to deal with it. But it's got a lot of functionality, like things like closed captioning, multi-language audio tracks, DRM. It's got ad signaling, audio normalization, so that you can support the COM Act and make sure that advertisements are much louder than normal content, and that's part of the FCC mandate as an example. Okay, so it's a full-fledged service that really enables you to deploy these channels in a matter of minutes, or deploy live events in a matter of minutes, and not have to worry about all of the heavy lifting that goes into it. So it's really built, like I said, for broadcast workload requirements. I mentioned some of the capabilities. The benefits of the solution enable you to deploy, whether you want to deploy user-generated content, you want to stream stuff from your phone, or you want to talk, or as a customer you have premium video, NFL, World Cup soccer, whatever it is that you want to deploy, you can use this service to deploy. Streamline setup and operations, like I said, you don't worry about it, we take care of it. And you can operate it really easily because it's very well integrated into the rest of the AWS console. So if in your account, we publish all of the events that are happening in your channels to your CloudWatch account. So you can set up your own dashboards in your CloudWatch account, and you can essentially, if you'd like to monitor and get alerts and alarms set up as well. And then in terms of pricing, it's really straightforward. It's either channel or event-based. So we have two pricing schemes. We have an event-based pricing scheme, which is essentially by the minute. You pay by the minute as you use it, not as you set it up, but as you actually use it. And then you pay by the month for long-running 24/7 channels. And it varies basically a little bit based on the kinds of capabilities that you're using. So it's a nice scale. So if you don't have premium video requirements, you don't have to pay for the premium video feature set. You pay for the basic video feature set. And at the bottom, you see a kind of a simple workflow. Andrew will go into some of these workflows in more detail. Okay, the second service that we launched is AWS Elemental Media Package. So this is a just-in-time packaging and live origination service that enables organizations to really target multi-screen users. So where you're looking to target users beyond a single device or a main screen, you're looking to target as many users as possible, this service gives you the ability to do that. So it's a video packaging and distribution service. And again, it deploys in minutes. You set up a channel. You give it inputs coming from the encoder. It takes the input, essentially does the packaging, does the indexing, and has the content ready. When a request comes in, it does the ingestion and the indexing. When a request comes in, it does the packaging, the encryption. It's got built-in DRM and serves it out. It scales automatically, so whether you want to deploy 1 channel or 100 channels, it's a multi-tenant service. It's a service that is regionally redundant, which means within a region we have multiple instantiations of the service, all behind a application load balancer, and we manage that. It does just-in-time packaging, I mentioned that. Content protection, it's an important piece for many of our customers. It interfaces with the 3 DRMs I mentioned, and we have over half a dozen key providers that have already integrated into this service. So if you wanted to use Verimatrix or Irdeto or CAS Labs by DRM, Easy DRM, there's a whole series of DRM key service providers that enable this. And then it also enables advanced features such as live to OD. So for example, the service comes with a 72-hour buffer. So your live stream that's coming in, the last 72 hours are accessible in a buffer. So if, for example, you wanted to deploy start over technology, which means that if your customer, if your consumer, if your video consumer happens to join a live stream that's already started, as an example, a game that's 5 minutes into it, You can deploy a solution that allows them to say, I want to start over. I want to watch it as if I'm watching it from the beginning. And we can just serve that by manipulating the manifest the right way. We serve out a manifest to that particular viewer that happens to start exactly when they've tuned in with the beginning of the game. So we do that amongst many other applications. Catch up and start over are some that we can deploy automatically. Okay. So like I said, the key benefits are that you can distribute content to all the different delivery protocols and all the different content protection standards to all the different devices so that you can really truly target a global audience. Okay. You can add live to what capabilities so your consumers are delighted by the fact that you have service innovation going on and you have new capabilities that matter to them. And then finally, because everybody expects these solutions to be highly resilient, highly available, that's exactly what this is. It's a multi-easy redundancy. It's got elastic scale. And finally, the pricing is very straightforward. It's based on how much video you ingest and how much video is packaged and originated. All of the pricing information is on aws.amazon.com. Go to the appropriate detailed page of the service, and you can see all the information there. Okay, I'd like to hand over now to Andrew, who's our product manager for MediaStor, to take it from here.
Thanks, Aslam. So the third new service that we launched on Monday that's live video focused is AWS Elemental MediaStor. And this service is really differentiated from a just-in-time packaging service or a traditional packaging video origin in that it is primarily a storage-based origin. So it's designed for either very simple low latency workflows or very high-end workflows where customers have a lot of proprietary tooling that they've built to actually deal with the rest of the ecosystem. So it's fundamentally object storage at its root. And it's a content origin because it's made to serve many, many requests, regardless of how many point of presences, CDN pops you have making requests every second. But perhaps most interesting, it's really designed to give you very low predictable latencies. And the predictability is actually one of the characteristics that we cared about most when we designed this service. Most object stores are designed for long-term storage at very effective long-term storage costs. And that comes at a cost from a perspective of giving you assurances that your content publishing, so your puts, your writes to your object store, and your retrievals, your GET requests, come at very predictable latencies. So you end up with degradation at the top percentiles of requests. And that sounds kind of niche, and it's actually not that niche, because if you think about a video that lasts an hour, if you're producing 10 bit rates, so you produce 10 video segments, it also has 10 playlists, which are little mini manifests that just show the video segments available for that bit rate. And let's say you have 2-second segments, you're producing 20 requests to your content origin. You're writing 20 times every 2 seconds. So let's say 100 CDN point of presences start reading it, right? You're talking about hundreds and hundreds, potentially thousands of read requests every couple of seconds. So obviously the numbers add up, right? So even a percentile degradation in terms of latency can result in a certain number of CDN pops that end up just not getting video in time, and that can result in a degraded user experience to end customers. We also have a strong consistency model, so we guarantee read after write and read after update consistency to the service, which is critical for manifest publishing. But it's also really critical for a whole variety of other use cases where you need a guarantee that the object you write when it's an overwrite of an existing object is actually the one that's getting served to end customers. It scales automatically. So while we use, I'll kind of go into a little bit of the detail in the next one. While we use a bunch of interesting technologies that are actually in front of S3 to give you this characteristic, we don't force you into a paradigm where you have to pre-provision a cache or prepay for some chunk of infrastructure, even if you're not guaranteed to use it. So the service really just asks you to continue to send it requests, and if you send 100 requests this second and 5 the next, you're only paying for the number of requests you send and the data you send into the service. And then it's backed by S3 for durability. So what we mean by this is the service actually intakes objects and replicates them across multiple availability zones for temporary durability into some high-performance infrastructure. It's essentially a replicated right behind cache. And we asynchronously actually move that object into S3 for long-lived durability. So there's a couple of advantages here. One, we're really able to give you predictable write acknowledgements. But two, we take care of a lot of the heavy lifting around actually storing that object durably. And it really enables workloads that need a lot of high performance at the very beginning of an object's life cycle, and then kind of degrades in its hotness requirement over time. We naturally degrade it. And just like S3, we have full IAM and resource policy capabilities, so you can control access to users, roles, cross-account, specific folders within your path, et cetera. So as I kind of recapped, you're accessing a durable, high-performance storage tier. Within minutes, it's transitioned to S3 for durability. It integrates with any CDN. So assuming that you create a policy for your resources that make your endpoints, your manifest, and your video accessible to public readers, you can take the origin endpoint and give it to any CDN, and then obviously that obfuscates it to the end customer behind your CDN endpoint. So it's not just CloudFront. You can use any other CDN provider. In fact, many of our customers use multiple CDNs. And it has incredibly simple integration. So it's fully integrated with the AWS SDKs. There's CLI for testing. It's got a console that lets you see the objects as they arrive, but really it's just for kind of some high-level management tasks. And the APIs are really quite simple because it's an object store. So any system that can speak HTTP and sign an AWS SIG-v4 request can talk to MediaStor just fine. And finally, pricing is really simple. It's an S3 plus model. So because your object is transitioned to S3, you're paying those costs. If you have an existing pricing arrangement with S3 or you have an enterprise discount plan, that all applies. And then there's an existing, there's an additional charge of 2 cents per gigabyte ingested into the service, no matter how many requests you make. So we're going to go through some live video workflows, and we're going to kind of detail, these are all sample workflows, so nothing's prescriptive here, but we're going to describe some ways that customers have integrated with these new services to distribute their video. So the first one is probably, it's kind of a trivial user-generated content workflow. So if this was your business, you would obviously want to refine this very carefully. But the concept here is that you take a source that produces a pre-encoded output stream like RTMP. So if you have an iPhone or if you have an Android device, there are apps on the marketplace where you can use your phone camera to output an RTMP, which is actually, oddly enough, a messaging protocol, but it's been used for video streaming for some time. And that is actually, underneath the hood, H.264 video. So that's a common video codec, and it's actually compressed. So it's compressed video coming out of your phone. And that can go to an EC2 instance like a T2 Micro. And it can run Nginx with an RTMP to HLS module, which with a few bits of JSON essentially takes that pre-encoded video and slices it up. So it's taking a continuous stream of bytes and it's chopping it into a fragmented media format that can then be used for distribution. And this is really important because in traditional user-generated content or like peer-to-peer or live streaming workflows, a lot of companies have actually just done stream replication. So if you're using like WebRTC or RTMP, you maintain massive fleets of servers that are going through and actually creating all of these output streams so that each individual device watching it can receive one. That's obviously not scalable, and if content gets really hot really fast, your ability to scale with it just is virtually non-existent. So this type of workflow enables you to essentially take that real-time stream, chop it up, add a little bit of latency at very additional cost, and then put it in a very high-speed origin and serve it directly out to your customers. So in a workflow like this, the latency that we were pushing out from a phone-held camera to you seeing it via your CDN was 3 to 4 seconds, which for most peer-to-peer broadcast with interactivity is completely acceptable. So the next workflow is one where you are encoding the stream into the adaptive bitrate set on the ground and actually pushing it to a cloud-based origin and then CDNs. So the use case here is that a large number of customers have existing ground encoders that they purchased a long time ago. Or they want to rely on TCP/IP to essentially handle transmission of the data rather than working on streaming protocols. So obviously, if you use if you make a normal put request to a service and you get an acknowledgement, it handles things like packet loss correction and transmission for you automatically. That's not true with other streaming protocols. So without error correction built in, you can lose bytes. And if you lose bytes when it tries to re-encode it in the cloud, then you don't get a very high quality picture. So some customers who have legacy encoders or who are really more focused with guaranteeing transmission or have a variety of other use cases like event production where internet connectivity might be unreliable, so they want to make sure they have the ability to retry sending video, will take the adaptive bitrate bouquet that they create from a ground encoder like AWS Elemental Live, which is a ground server product that Elemental's been building for 10 years, and actually push that set of segments into an origin like MediaStor. And then that is served out to an end customer. So Chris is going to talk a little bit more about this use case a little bit later. The final workflow we'll talk about, and then we'll kind of dive into the console for this specific use case, is kind of the what I would describe as the full broadcast workflow. So this is where you are taking a live streaming protocol in, as Aslam was talking about. So this is a contribution encoded stream. You are pushing it to Media Live as the primary encoder. It's creating an adaptive bitrate set, an encoded adaptive bitrate set, and pushing it to Media Package. Media Package then takes the content and, based on requests that are coming from your users, repackages that content in the format that is required to effectively deliver it. So that's really important if you think about the fact that if you have content that is being optimized for Apple devices, but suddenly you want to go offer it to people who have Android devices or smart TVs, it needs a fundamentally different packaging format that those devices understand. And so Media Package does that, but it also enables a whole slew of other features like Rewind TV. So if you're building the next generation of broadcast grade workflow and you want to build an application that has a really rich audience experience, then Media Package is definitely the service for you. And this digs a little bit deeper into what mezzanine encoding, so the contribution encoding, looks like. In this instance, this source is a live channel. Could be a baseband signal coming in over SDI to an Elemental Live on the ground, which is actually outputting a streaming protocol you can send into the cloud, like RTP with forward error correction or RTMP. Obviously, a lot of customers use AWS Direct Connect for this. It provides a nice, stable, fast platform for data transmission to the cloud. So with that, I'm going to dive into kind of what the console experience looks like for those. Got audio coming from a stream. So the first console I want to show you is the live encoder console. So in this situation, the demo, what I'll show you, the video I'll show you at the end is just a camera that we have set up at our office in Portland that's looking out on the street. But there is a on-the-ground Elemental Live that's creating a contribution encode, and it's feeding it to this live channel that we have set up on the AWS console. So the first thing that is really differentiated between the new console services we offered and what has previously existed in the market almost unilaterally is that the control plane you're accessing here isn't the actual like encoder box. It's the ability for you to go in and create your channel, create your encoding settings, really perfect your setup before you actually start an event, which actually triggers the generation of an actual encoder, which will then encode your stream. So like Aslam said, you don't actually pay while you're sitting here doing configuration. And that's a lot different than if you go spin up EC2 instances with a AMI that contains a third-party encoder, or even legacy cloud platforms where you actually spun up resources where you're paying by the hour, even if all you're doing is configuring channels. So Media Live is really all about go configure your parameters, your inputs, your encoding parameters, what your outputs look like, start your event, and really it just starts kicking out video. So some details here, there's some administration details. Generally speaking, we offer a pretty rich set of diagnostics that allow you to see various alerts that get published. So, Aslam, I don't know if you, off the top of your head, have ones that are super critical here. But a majority, alerts that allow you to know if something's gone wrong. Network in and out, frame rate's obviously important. So if you start dropping frames, that it's going to be a degraded user experience. You don't want to be running a 1080 P60 stream that people care about live sports on, and then all of a sudden go down to 10 frames per second. It's going to be pretty jittery.
Yeah, so those two at the end there, drop frames and SVQ time, are both critically important.
Yeah.
You want to make sure your drop frames are at 0, and your SVQ basically is an indicative of your quality of your video being produced. So as long as the SVQ is also flat, you're in a good place.
Can you explain the SVQ concept?
Yeah, SVQ is basically a speed versus quality setting that we have. So because it's a real-time encoder, remember, timing is really critically important. You cannot afford to not encode a frame when it's time to encode and publish that frame. So if the frame is really complicated, or if there is a lot of complexity in it, we may have to vary the quality to make sure that we keep the speed going, right? So that's the speed versus quality setting. And you can, if you tweak up the quality setting, then we have to deploy more resources to keep the speed going, and therefore you kind of end up paying more. So or if you tweak it down and you say, I don't care that much about this, I need consistent, maintained quality, you can tweak it down and you pay less because we put fewer resources to do the transcoding work.
And that's really highly differentiated from existing encoding solutions on the market, where if you have a encoder and it just can't keep up, that's it, right? It's not going to elastically scale resources to make sure that it gives your stream the quality it needs. I'll dig into inputs. So the input process essentially allows you to create various redundant inputs into the encoder. So as Aslam mentioned, redundancy is a key component of Media Live as a service. So previous incarnations of encoding services that were in the cloud or even the ground really force management of redundancy onto you. Not only managing your input redundancy, but also managing provisions of encoders and making sure that the outputs were actually managed the same way. Media Live allows you to push dual streams, and that essentially redundantly creates a channel configuration where if for some reason one encoder were to crash, your stream would continue to be produced, and your origin can continue to receive video segments. The other concepts here are outputs. And so the outputs are essentially the definitions of the video that's coming out of the encoder. So if you look at a lot of the data here, it obviously gives you a pretty rich set of properties that you can configure. So it's not like you're just saying, here's the target resolution I want. You can play with everything from the number of B frames to a group of picture size. This is important if you want to play with various quality settings. There's also variation in the codecs that are available. So obviously this is using standard H.264 video. The audio features allow you to have different audio codecs depending upon your output. Any other key features, Aslam, that you want to highlight as kind of things that are differentiated from other offerings?
Oh, I mean, this is just a summary. If you really go into configure your output, you'll see a whole series of knobs and levers that you can use, including very detailed things about what filters you want to apply, what deinterlacer you want to do, whether you want to do frame rate conversion, how do you want to take care of advertising metadata that's coming in the input stream. Do you want to use audio normalization? Do you want to do Dolby? Which Dolby do you want to use? You want AC3, EAC3, Dolby E? So there's a very rich set of capabilities that you can configure if you so desire.
And it's not like, there's obviously a pretty rich console experience, but they're all fully accessible by API as well. So a lot of our customers create their own automation where they essentially provision these channels. They go make an API request. While a lot of the channel is set up, you can start it, off it goes. So the second component of this workflow is the actual packaging component. So Media Live pushes HLS to a destination. What was that? Yeah, it won't take a few moments. Pushes HLS to its destination. So it basically gives you some input URLs. Media Live pushes HLS. And then Media Package, just like Media Live, is giving you a set of operational metrics that's telling you how it's ingesting data and how it's egressing data. The basic configurations that you have with Media Package are these. You're creating essentially what you want your finalized outputs to look like. So it's not like it's not like you have to serve everything, right? So if you only want to serve HLS and Dash, that's totally acceptable. It's got a whole variety of other filters that really allow you to customize the experience, your live to VOD window, your playback window, et cetera. And the final output, is video. So this is live video from the street in Portland. It's not raining, which I'm pretty happy about. Surprising. But so this goes from Media Live to Media Package to CloudFront. If you scan the QR code, it'll start playing on your device because it's repackaging it in whatever format your device is going to request it in. So with that, I'm going to turn it over to Chris.
Thanks, Andrew. Pleasure to be here today. All right, so Pac-12 Networks delivers games to the fans of the schools of the Pac-12 Conference, and we're also fully owned by the Pac-12 Conference. We started broadcasting and streaming in 2012, and we've been fully producing about 850 live games a year. I say per year, but it's actually for the school year, so that's a lot of games on a Saturday morning. If you want to access all the live content in the US, you authenticate with credentials from your cable or satellite provider, and you can also receive our network streams throughout the world outside the US. The 12 schools of the conference also produce another 350 or so live events a year on their own and stream them through pac12.com. There we go, thank you. That makes more sense. And stream them through pac12.com. We also produce quite a few studio programs and original programs, all telling the stories of our student athletes, their coaches, and fans. So we've had a pretty solid streaming solution, delivering RTMP and a pair of gigabit connections over the public internet to our CDN, and they repackage it to HLS. So why move to the cloud, and why use Elemental Media services? So first of all, I have to say I have tremendous respect for Aslam and Andrew. The entire AWS Elemental team has been great, and they're really top-notch, from sales, engineering, all the way support. Next is reliability. We've occasionally had some extra network latency and packet loss on the connection between our encoders and our CDN's entry points. So that caused some issues that were hard to pinpoint without much visibility into the process through our CDN. So we wanted to maintain our own origin, and so we could get real metrics from every point along the chain. So by switching from RTMP to HLS, we can now just deliver those segmented files to MediaStor, and those segments can be cached in MediaStor and at the CDN. So another win is that we can permanently store those segments in S3 for reuse as VOD content. But I think the most important reason that we're migrating to AWS Elemental MediaStor is the potential for integration with other AWS services. So once we have that segment of media in MediaStor, we can use any of the other services that with the media. So I tried recognition in Leah's Cat Finder workshop earlier this week. I can't wait to try Amazon Transcribe for captions. We can automate MediaStor with CloudWatch events or invoke Lambda functions or step functions or notify an SNS topic or an SQSQ. So they keep coming out with new services at an amazing pace, so I bet we'll have lots of new things to play with next year. So let's take a look at our new streaming infrastructure. It's fairly simple at this point, at least for this use case, but we're thinking about lots of other use cases in the future. So we're still making ABR renditions on our AWS Elemental Live hardware encoders at Pac-12 networks, but now we're segmenting those as HLS rather than sending RTMP to the CDN. And then we're sending them to MediaStor, which serves as our origin. CloudFront can pull directly from MediaStor and deliver those segments wherever we need them. We've also added a direct connect, so we can use that for moving the segmented media up to the cloud. And I also just tried out Elemental Media Live and Media Package, and I did it for the first time this week, and we're excited to try that on some of our school-produced streams. So it's really amazing how many media services AWS has launched this week. I think lots of media organizations will find ways to combine those services to build new solutions. So thanks again. I'll give it back to Andrew, and he'll tell you more about the services.
Awesome. Are you going to take us home?
No, you can show the.
Did you want to show the the live
Let's plug in the stream.
the live demo?
And we're going to watch some Pac-12 Mountain.
Pac-12 is a mountain. Yeah, that's right. So this is the output of CloudFront through that chain.
Chris, have you measured your end-to-end latency through MediaStor for your live channel?
We haven't. What would you expect it to be?
You know, depending upon, you're using 10-second segments,
Yeah,
right?
right.
So, I mean, you're going to have at least 30 seconds of latency built in.
Yeah, we're at about a minute with our previous solution, so that's cutting it in half.
So this is what it looks like. I mean, this is video coming out of your playout system, correct?
Yeah, so this is actually goes through a satellite pass, so this is up and down through the satellite to our IRD, through our Elemental Live encoder, up to MediaStor, through the CDN, and out from CloudFront, through Wi-Fi to your laptop.
Yeah, looks good. And your top bit rate is 1080p?
1080p at about 5 megabits.
5 megabits.
So that's probably what you're watching here.
Yeah. Great.
Great.
Thank you, Chris.
Yep.
Let me switch back. Did you switch back? Automatically. Okay. All right. So you know, it's a pretty amazing thing to see a video stream just play out for people like us who are behind the scenes, know how much work it takes to get it going, and just being able to essentially stream your segments over and have it show up on any device that you are using is pretty phenomenal. So we're really excited about the possibilities, and I hope you are as well. So kind of just to wrap it up, we essentially, these services, if you just look at the live streaming use cases, essentially are intended to cater to both events where we see a lot of usage possibly happening because of the scalability, the flexibility, the agility, the pay-as-you-go nature of these services, that you can essentially, at a very, very, very inexpensively deploy broadcast-grade live events. And that's really a significant promise of these services. And again, there are a large number of different use cases, and this is not just about premium content. It's not, we love seeing football, and, you know, but there are use cases well above and beyond premium content. And then secondly, we are seeing definitely the use case, and we've done this now with a number of customers. Actually, we have a customer that's deploying at this stage, has already deployed close to 40 channels, 24/7 channels using Media Live, Media Package in the Asia Pacific region. And they've told us they expect to ramp up to about 200 channels. These are 24/7 channels. And the economics, so in combination with the broadcast grade capability, and broadcast grade covers a few different things. It covers obviously capability, it covers resilience and availability, and it covers quality. And all of those are really important. So alongside that, you have a really competitive service from a pricing point of view as well. So essentially, to wrap it up, on Monday, we introduced the 3 services we spoke about today, as well as 2 additional services that we did not talk about today in this session, but is being spoken about elsewhere, and that's the one on your bottom, the WAD workflow, AWS Elemental Media Convert, which is a file-to-file transcoding service, and AWS Elemental Media Tailor, which is a server-side, highly scalable server-side ad insertion, content personalization service. So altogether, if you then take these 5 services and lay them out in your distribution workflow, we feel that we have fairly comprehensively covered the video pipeline from that perspective. Of course, you need a number of other services around it. You need content management systems, you need subscription management systems, you need DRM key service providers, and there is a rich ecosystem within the AWS marketplace as well as with other AWS partners that bring all of that to bear so that you can put together really comprehensive end-to-end services. That's all I have for today. Thank you very much for coming and being here. If you have questions, we're all right here.
Over there,
and talk to us.
Thank you, everyone.
Thank you very much.